So we just introduced a thing that when we are having a distribution of sample mean, saying that it's normal and the mean is 1000 and the standard deviation is 20, we say that we want to find a cutoff value such that the left tail probability or the right tail probability is just 2.5%. Okay, so here in the slides, I just get this 39.2 directly, or we get like 960.8, blah, blah, blah. We get those values directly without any derivation. Why is that? Because we use Excel to do that, or we use any software to do that. So now what I'm going to do is to show you that at least in Excel, we need to know how to get that 960.8 by having this problem setting. Okay, so let's come here. I have a normal random variable where the mean is 1000 and the standard deviation is 20. I also know that I want to make a condition satisfied, saying that I want to find a cutoff, or I should say a lag length d, such that the probability for my random variable x to deviate from 1000 is greater than d is probability 5%. Okay, or if I only look at the left part, or if I only look at the right part, I get half of it. So that's why it's 2.5%. Okay, so all of these are problem settings. Now our question is, how may we find those two numbers, 960.8 and 1039.2? Okay, so let's do it. The idea is very simple. Basically, I have a normal curve, and I have three values to use. I need to have the mean and the standard deviation to be input into a function so that I construct that normal curve. And then I need to accumulate the probability starting from negative infinity, and I need to move on until I get 2.5%. So in Excel, there is a function that allows us to do that. The function is called Norm.Inv, normal inverse. That means if you give this function a left tail probability as the first argument probability, and you also tell the function what's the mean, what's the standard deviation of that normal random variable, then this function will tell you cut to where such that the left tail probability is the probability that you want. So in this particular case, we just need to enter these three numbers, right? Because this is mean, this is standard deviation, and this 2.5%. This 2.5% is that particular left tail probability that we are looking at. So that's why this is 960.8. For the second one, it's just the same. It's that I still have the same normal curve, but now I'm looking at the right tail probability to be 2.5%. And exactly that means my left tail probability should be 97.5%. So that's how I do this. I get 1 minus b5 to get that 97.5%. Put that into this normal inverse function. That's how I get 1039.2. Okay.